metal operation are here to speak about the design aspects of sheet metal parts. Our team consists of members Swapnali Tepta, Tanisha Jain, Tapas Mandal T, Akash Singh, Angur Sabbo, Abhas Hota, and Ritik Kumar Sahu. Design aspect of sheet metal operations. Sheet metal is one of the most versatile and widely used manufacturing methods. It has significantly lower cost than machining cavities into metal blocks. Sheet metals are generally classified as metal sheets that have a thickness ranging from 0.4 mm to 6 mm. Different metals such as steel, aluminum, copper, brass, nickel, titanium can be made into sheets by rolling process. Sheet metals are widely used in industries such as aerospace, automotive, electronic appliance, construction, etc. Design methodology of sheet metal parts. For making a sheet metal component, following steps are performed. First step is material and size selection. The selection of materials depends on the application, formability, weldability, corrosion resistance, strength, weight, and cost. The thickness of the sheet is decided on the requirements of strength. A detailed comparison can be made using the available design data handbooks with different material specifications. Designing. Below are the factors which one needs to consider while modeling a sheet metal component. Wall thickness. While designing any geometry, it is always a good idea to maintain uniform wall thickness throughout the body. Geometry with more than one wall thickness requires sheets of different thicknesses, which requires reorientation and alignment of parts that consume time. Parts with different thicknesses will have different bend parameters which may result in inaccuracy of the desired shape. Now I want Tapas to carry forward the presentation.
Thank you. When ready. To avoid any fractures or distortions, it is necessary to keep inside bend radius at least equal to sheet's thickness. The bend radius should be maintained consistently throughout the part as keeping the same bend radius across all bends makes the part cost effective. When making a bend, it is always preferred to make bends in a single plane. This will avoid any additional reorientation while manufacturing the part. Oriented holes and slots. Keep holes and slots diameter at least as large as sheet metal thickness. Holes diameter less than the sheet metal thickness result in higher punch loading. Longer burnings in the holes and expensive burr. If the hole gets too close to an edge, a bulge can appear near an edge. Spacing between holes should be at least 2 times the sheet metal thickness. Next, K factor. The K factor in the sheet metal working is the ratio of the neutral axis to the material thickness. K factor changes its value with respect to physical properties and thickness of the material. General values for K factors varies from 0.3 to 0.5. Thank you. Over to next.
So the next one is bend reduction. It is defined as a material that needs to be removed from the root length of a flanges to arrive at the flat pattern. We're trying to develop a flat pattern, the reduction has to be subtracted to get its overall length. Next one is bend relief. Bend reliefs are implemented where a bend extends on an edge. The relief notches are added to prevent tearing and rebending of the part. Relief helps control unwanted sheet metal deformation. Bend reliefs should be at least same as the thickness of sheet metal in terms of weight and should be equal to or greater than inside bend radius in terms of depth. Bend reliefs can be rectangular, tear, and around. Some additional features which are required to consider while designing a product are as follows. Hems are folds at the end of a part to create a round edge and is recommended to have minimum inside diameter and is same as the material thickness, and the hem return length should be minimum 4 times the sheet thickness. Over to Avas.
Now, create engineering drawings. After designing and completing a 3D model, Drawings are created for manufacturing. Flat patterns are included in drawings to show bent lines. A bend table is included in the drawing that indicates the angle and direction of bend. Drawings include all the information that is required for manufacturing, such as surface finishing, coating, plating, etc. The next one is manufacturing process. After designing the product, we follow different manufacturing processes to manufacture the product. The first step of manufacturing a sheet metal production includes cutting the sheets. This can be performed by laser cutting, water jet cutting, or by mechanical shearing. After that, various sheet metal operations such as bending, drawing, etc. are performed to get the desired shape of the product. Over to next.
So now let's discuss about fabrication process. Once the sheet metal model is formed, the corners or open gaps are welded to maintain the strength and geometry of the component. Welding methods that are generally used are TIG, MIG, spot welding, etc. For aluminum and brass parts, brazing is used for joining. Besides welding, riveting can also be considered for joining. Post-processing process. The welded sheet metal components have to be surface finished to remove the sharp edges and to optimize the cosmetic appearance of the product. This can be achieved through hand grinding, jitterbugging, white belt sandpapers, buffing, etc. Platforms. We can use different CAD software such as Tinkercad, FreeCAD, BlocksCAD, Creo, Fusion 360°, SolidWorks, AutoCAD, CATIA. Also, one can use drawing sheets to carve out their designs. To conclude, one should effectively use the following sheet metal design guidelines as per the application, which can help in reducing iterations and cost. Also, the cycle time can improve during manufacturing. An experienced sheet metal designer becomes imperative to have all those parameters into consideration. Hope we, the members of Team Sheet Metal Operation, have helped you with all your sheet metal design requirements. Thank you. Do like, share and subscribe to our YouTube channel too.